Okay, so I'm not sure if you've looked in the glossary and found what each of these three things is here. But essentially, if you have a triangle that's a right angle triangle and you have those three sides, you can make three pairs of sides. I'm just going to put we'll put it hypotenuse. If I'm looking at this angle right here, that's the opposite side. I noticed some of you were putting these two backwards, adjacent and opposite. Probably best if you look for the opposite side first. But if you have those three sides, how many pairs can you make from those three sides? How many pairs can I make? Like this is one pair, opposite and adjacent. There's a pair, right? I can match those two up. What other pairs could I make? What other pairs? I could do this one, right? Adjacent and hypotenuse. There's another pair. That pair is actually going to go with this one right here. And then what's the only other one? There's only one other way you can pair them up. Tangent's actually going to be the yellow one, the opposite and adjacent. But the two that aren't matched up here are these two, right? Like if you have three objects, there's only three ways you can pair them up. If you have three people, there's only three ways you can pick two of them, right? If there's three sides, there's only three ways you can pair them up. You can have opposite and adjacent. That's actually called the tangent ratio. If you measure the opposite and you measure the adjacent and you divide that for a triangle, that's called the tangent ratio. Opposite to adjacent. So if you take the opposite and you divide it by the adjacent, that is called the tangent ratio. If you take the opposite and the hypotenuse, which is the first one you did in that activity, you get the sine ratio. This is opposite to hypotenuse. Okay, so we got opposite, hypotenuse. And if you haven't got this filled out, you probably should do that right now. That's what I would say. Or you can scribble some notes down at the side. You could draw that little triangle. If you had highlighters, you could do that. That's pretty effective maybe at helping you see what it actually means there. And then the third one is the blue one there, right? The adjacent and the hypotenuse. Okay, so if you take the length of the adjacent side and you divide it by the length of the hypotenuse, that gives you what's called the cosine ratio. So you have those three. There's abbreviations for them. Like there's the full word tangent, or you can use the abbreviation which is just TAN, the first three letters. But we should still, even if you see that written, just the abbreviations, you should still say tangent, not just tan. And it needs to be, when you write this down, you need to have a name for your angle, M or something like that. Because the way you write this is you say tangent of angle M. Like the tangent ratio for angle M. This is how you would say this in words. This part right here, you would say tangent ratio for angle M. And if you would rather put that not scribbled underneath there and put it over the side, that might be a better place for it. I'm going to move it now over to here, so it's not so hard to read. So when you're using this, the shorthand again is, instead of saying tangent ratio for angle M, you can just write tan M, like that. Just like a lot of other things, right? The square root of a number, the square root of 6, you can just write that symbol, but you got to know what the symbol means. The symbol is letters here, which helps, but now up to this point, if you have a triangle where you either measure the sides or you're given the sides, I think after today you should be able to write the different ratios. You're probably going to have to refer back to this. When you get to the provincial exam, you're going to be given a formula sheet that has this stuff on it, that has this, reminds you of what the three ratios are, but probably before then you're going to end up memorizing it just by working with it all the time. Okay, you're going to remember what each of them are. But for now, you might want to have to refer back to that. If you look up at the list up above, it says the sine ratio is opposite over hypotenuse. So that's all that's happened here, right? The sine ratio is the opposite over the hypotenuse. this is from this angle here. If you're talking about sine of angle A, you got to look at what angle you're talking about. That's this angle right here, right? From this angle, that's the opposite, right? So it matters which angle you're talking about. This says sine of A. It doesn't just say sine, it says sine of A. So from angle A, that's the opposite, and that's the hypotenuse. So it's 7/25, right? 7/25. Simple, right? You don't even have to divide them. I don't even care if you divide them or not. You can just leave it as a fraction right now. Cosine of angle A would be not the opposite over the hypotenuse. What's the cosine up here? What does it say? It says cosine is adjacent over hypotenuse. So then you look at what the adjacent is and what the hypotenuse is. Right, so the adjacent to this is this one. This is the adjacent side. So this is going to be 24/25. All right? You can finish the rest of them here in a minute or two. This one, notice it says sine of t, not sine of A. So then you need to, if you're doing that, you need to kind of relabel the triangle. What happens if we look at this angle instead of the other angle? If you start looking at angle T, what happens? What happens to the adjacent and the opposite? They switch around, right? So you need to look at it from whatever angle you're required to look at it. The second example is slightly different. Now, when you're working through these booklets, why would I choose, or why would a book choose to put a title on an example and not just say example 1? Like it says example 1 and then a title. Why is that? What do you think? So you know what you're learning, right? When you do this, don't just skip over this. I think a lot of people just skip to where they see the question. Not a good idea, right? Read the title and it'll tell you what you're going to learn, right? So this is writing trig ratios given the side lengths. And then you read the next title of the next example. Before you even look at the question, writing trig ratios with a missing side, how do you think the picture is going to look different? I know you can see the picture now, but how is the picture different? How's the picture different? Let's have different people's... Yeah, it's got a missing side, right? This one you don't know. In this picture, this one you don't know. I put 2 examples in here because I thought they're slightly different. The triangles are different, but also there's a significant difference to which side is missing. You're going to need to think back to what you've learned in the past about how you find the missing sides. If I had thought about it, I would have put a little hint here and said, you remember something you learned in grade 8? That helps you find missing sides in right triangles. Okay? What you need to recall. You need to recall how to use the Pythagorean theorem. Pythagorean relationship, you might have called it. Or if some of you are more visual, you might remember a picture like this, right? In grade 8, you learned this idea that this... If you made a square on there and you made a square on here, I didn't leave myself enough room to make the last square, but what should that equal if I add those 2 things up? If I make a big square on this side, so if you're a visual person, that's probably what you're going to remember. Now, I'm drawing it so that it looks like a square on here, and then when it projects, it's still okay. If you have this side is length A, and this side is length B, and this side is length C. This is A squared, this is B squared, and this is C squared. And the relationship is A squared plus B squared equals C squared. So whichever way you learned it, visually or with the formula or both, you can write one of the ratios first here without finding the missing side. Which one can you write given the two that you're given in the triangle? Which one can you write? You can write the tangent here because you have if you're talking about angle H, that's the opposite, that's the adjacent, right? From angle H, this is the opposite, and that's the adjacent. So you could write this one. You could write that this is, which way? 8/6, right? But to write the other 2, you need to find the other side. You don't have to, you can just do it over at the side here, and you can write it. If you're visual and you're going to do this, you're welcome to do that. Or if you want to write the formula out and say 6 squared plus 8 squared equals, you could call this hypotenuse squared. You could call it AH. You know, like you could, unfortunately I used the letters A and H in there, which might be a bad idea, but you could call it X or whatever. x squared, doesn't matter what you call it. Usually in a triangle, if you want to do it the traditional way, if you need to give a variable to a side, the variable you give is the small letter for the angle that's across from it. So if you want to be cool like mathematicians are, you could say if that's capital letter G, this is small letter g. Okay? If you want to be rebellious and anger the math gods, you can use something else. But whatever, it doesn't matter. I used x, so we'll stick with x there. If you work your way down here, I'm not going to do this whole thing for you, but you have 36 plus 64. You have 100. It's almost like I picked that so it would work out to be a really nice number. If x squared is 100, what's x? Well, I'm going to write square root of 100 first because I'm a little slower than you. You guys are quick and you jumped right to the conclusion that it's 10. This is you could just write 10 on here if you want. Okay? And then normally we won't even need to show maybe so many steps of this now because it is a grade 8 thing, but that thing is 10. Once you have 10, then you can write the rest of the ratios. So it's almost like I picked this so it would work out to a nice number. And it's almost like I picked this one so it would work out to not a nice number. If we're writing the trig ratios and we're saying that this is equal here, we want to find out what that is. If I was to find this same thing for this missing side, you'll find this doesn't work out so nicely. And this is one of the smaller sides here. I'm going to just call this, I'm going to call this little letter a. If I want to write the Pythagorean relation for that, how do I write this? Do I say 2 squared plus 5 squared equals a squared? Is that right? This is the biggest side. It's the hypotenuse, so it should be by itself. So it's not going to be like this. The 5 squared has to be by itself, so you got a squared plus 2 squared is that. If you work your way down here, you got a little equation you can solve. Again, if you haven't done this or this is unfamiliar to you, you might want to copy it down, right? So you have something to look back at later. A squared is 21. Is that a number that works well? Is that a number that works well? Well, I mean, it's not going to be a whole number, that's for sure. Can I, off the top of my head, do you think I can say A equals and put the exact answer here? Again, if you're not listening and not writing stuff right now, it's probably an idea to do at least one of those things, right? I do not have a calculator in front of me, and neither did the Greeks who first used this idea. So instead, they would just say, whatever it is, it's the square root of 21. I can put an equal sign there because it's exactly equal to the square root of 21. If I go to my calculator and try and write a number for that, I have to suddenly put this weird equal sign and say it's roughly 4 point whatever. But that's going to continue on forever here, right? You're going to have to put ... and write this number out. So for what we're doing, it's easier if you just stop at this and say, I don't know what that is, but I do know it's the square root of 21. So you can use that exact number. It's actually easier. Some people freak out in Math 10 because they say, look at this fraction involves a square root. That's crazy. A fraction with a square root in it. It's actually easier because otherwise it would have to be 4 point, who knows what, 5, blah, 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 over 5. We don't want that. We want to write exact answers because I want to be able to say equals something with an equal sign, not with this wavy approximately equal to sign. So for this, let's leave that off and let's write an exact answer. This is an exact answer. Use the exact answer here, the square root sign, okay? The answers are right underneath there, but maybe you could perhaps test yourself by covering it up with a piece of paper, trying to write them, seeing if you're right. You have the responsibility here, right, to check that you can do this. Every single day you learn something new, and as long as you learn it and you understand it, the course will be easy, okay? It's as soon as you get off task, leave here not understanding it, don't do something before the next class to make sure you do understand it, that's when it becomes difficult. Not hard to do well if you're here and using your time and you leave here understanding it, or you make sure you understand it after you leave, okay? Can you make sure you do that? And then there's just something to check your understanding, these two puzzles here. They're right after this. If you do those two puzzles, that's what we want to aim to do by next time. Okay? Can you get going on that?